Hi, everyone. Oh, glad my mic is working. Thank you. So let me start with a promise. At the end of this talk, everyone in this room will be a skilled hacker. No, maybe not. But at least you'll have a glimpse into how attackers think and what it takes for defenders and people in your teams to be ready. Here are two lovely individuals, Mr. Hacker and Miss Security, that have very tough challenges. Mr. Hacker has to hack, and Miss Security has to make sure he doesn't get in. Take a second to think about who in your mind has like the toughest challenge. Raise your hand if you think it's Mr. Hacker. Well, no one. Miss Security? All right, so it's pretty clear that like everyone thinks defending is harder, right? And it might come from some of the old saying we think about that like attackers have to be right only once and defenders have to be right all the time. Thinking this way is absolutely terrifying, well, at least for me, because I'm trying to help defending and people defenders, right? So what has a ring to it? Let's try to unpack this a bit and see that like it might not actually be that obvious. So when we look at modern systems, they are optimized for velocity, right? Like velocity means faster innovation. Faster innovation means bringing more things to market. Bringing more things to market means money. And so that's literally great for the business. And what it takes to get there is, and what we've seen with our friend at Vodafone and at Box is, well, distributed systems, primarily in the cloud, ephemeral workloads, like environments that are quite complex. And we think about environments like that, it also means they are like harder to attack. They are harder for people that are like without knowledge to make sense of. And so when an attacker is trying to achieve their goal, which is usually money, either through disrupting your operations or stealing sensitive data or taking over some resources to run some things on your AWS bill, that's not necessarily easy. And it requires new attack practices. And so today, I'd like to take a few minutes to walk through realistic scenarios with different things we've seen in the wild and see how attackers operate in those cases. There are basically two main ways we think of when we need to enter through an organization. The first one is employee laptops and things like this, which we're not going to talk about today. And the second one is the applications that you have, by design, usually exposed on the internet because you want your customers to review their Vodafone usage. And so in this case, what they'll do is they'll simply start by scanning those applications, scanning those endpoints, and trying to understand what your application does. This is something that takes a little bit of time. They use attack tools like Arachne, for instance. It sends hundreds of requests, and a lot of them are usually typically not finding anything, 404s, 500s, like things like this, especially if you need authentication, right? And so they are mapping your application, discovering endpoints, and starting to gain information about what your system might look like and might do. The next thing they need to do is, if you're authenticated, they need to establish accounts and try to understand, like, map your application at a further level. And they are looking for something they deem interesting. Usually what that means is they're looking for like a weird behavior, a bug. And in this case, if they find a bug in a specific endpoints that might be interesting, they're going to dig further. Not all bugs are security issues, hopefully and thankfully, but some of the times, like some of those are, and like it takes a bit of skill to turn a bug into a vulnerability. And so once again, like the attackers will have to like dive deeper, and get in your infrastructure that way. So this is where, like, you can see at this point, the attackers have like found a vulnerability and established initial access to your infrastructure. Well, they haven't done anything yet, right? They haven't made any money, they haven't done anything. So while they've like breached technically your application, they haven't achieved their goal. So they need to keep going. What they want to do next is exploiting the vulnerability to achieve what they want to do. In this case, we're going to take an example where they're going to run a crypto miner. There are different things, different type of malicious code they can run or malware. But let's take a crypto miner as an example first. because malware is basically software, they need to figure out a way to deploy it, and they need to figure out a way to make sure that the environment has the necessary tool for the malware to run properly. As you have a CI/CD and you go there, you typically have things to provision the infrastructure the way it needs to be, right? So in this case, they might have a script to install different packages they need, and they're going to download the executable or the file to make sure that file they need to execute is on the server. And they're going to find a way to make sure this file is executed, in this case, maybe through a cron job. And in this case, take over your CPU, your resources, and bravo, like they made money, they're happy, they ran their crypto miner, and you have been compromised. The thing is, as we discussed, like more and more workloads are ephemeral, and if you're running a crypto miner on an ephemeral workload that goes up and down, well, like what is the end value here? How much are they going to get from it? And so what we see attackers do, and a different way to exploit vulnerabilities is to look for something more valuable, right? When they entered your infrastructure and your systems, they're not quite sure where they are, but they want to access things that like will bring them more value. And so this is what we call lateral movement. A common thing and a common pattern we see is you have more access to other resources when you're within the infrastructure. And so some of the things they might be able to do is look at cloud metadata services, or IMDS. The V1 is by default insecure from within the infrastructure. And they have access to credentials and things like this. So they can list the credentials that are stored in IAM and then take over like accounts that they deem privileged. And now we're starting to have an impact that is non-negligible, right? Because once you have like an IAM user that like has access to all of the different services that AWS can provide, they can leverage this in many ways, like create resources and host fraudulent sites, which we've seen. Disrupt your operation or steal sensitive data that you have stored in different databases, EBS, et cetera, et cetera. So in this example, let's say they're going to list the services you have in use. They might create admin accounts for future use and steal sensitive data by making a copy and a snapshot of your database and then share that openly. And so it took me maybe 5 minutes to walk you through this attack path, right? And what I did is I went through quite a sophisticated way, and this is what we typically tend to see. It's not once and done, but it takes a lot of effort, right? And there are two things that are very important to note here, right? First of all, it takes a combination of security issues to reach to like the point we have something really, really bad happening, right? We saw like there's a vulnerability in the application. We saw the credentials was overprivileged, et cetera, et cetera. The second thing that we see is that it takes a lot of activities, and I only went through like the successful pieces of the activity, but the attacker is going to try things and like he's going to go like trial and error. So we have, as defenders, the opportunity to catch things as they happen, and there are a lot of things to look for. And so how can organizations better prepare themselves to catch this kind of things, right? There are two main aspects into security. The first one is being proactive, so identify the bugs that might be security issues. In this case, I've listed a bit the things we've seen in the attack path we looked at today. And then there is reactively, right? Being alerted when something bad's happening, and you got to access like everything that happens at the different layers, right? From the application, your API, your workload, and the accounts, and then the cloud anomalies you might detect. And so I'm a Datadog product manager. I love talking about our products. And so let's see how Datadog can help with this sieve. I'm not going to go through all of the security acronyms because it would probably take all day. But there's basically three big categories of product. The first one is looking at the code, right? Is the code you write secure? And is the code you import secure? And so it can help with security, vulnerabilities, and risky APIs you have. The second is looking at how you use your cloud. Like, is the configuration of your cloud providers done properly? Are like the way you're leveraging credentials like over-provisioned and can be reduced to have the least privilege, right? And so same thing, we can look at all of these things and help you with that. And the last thing is reactively. How can we like monitor your applications and your hosts and your cloud environments for issues like that? And so that helps us prioritize issues with context in the first place. So here in this case, we see when an EC2 instance is using that like unsecure by design metadata service, and it's not a problem unless it's combined with what is actually accessible from the internet, and therefore someone could actually do something bad with it. The second thing is here we have all of the different like signals or alerts we could receive in the same place. So when we investigate a security incident, we can have all of the context at the different layers. And this context at the different layers goes very deep from the request itself with the body information, the process information on the host, which like which commands were run, and with the arguments, and last but not least, how those things were established at the cloud layer on the different activity happening at the cloud configuration layer. And so, if I can leave you with a couple of thoughts today in how to better prepare yourself, I would leave you with one word, which is being pragmatic as much as possible. And so when you're dealing with security issues, it needs to be prioritized because that's not what is the most important things for you to do for your business. And it needs to be prioritized with exploitability and impact, as well as the context from the business standpoint, but also the runtime context to see if those things can actually lead to bad things. And the second thing is, as you all do from a reliability standpoint, you're learning to handle reliability issues, you're learning to like catch incidents, you're learning to be on call, and you have the right tools in place to do this, right? So you want visibility at all of the different layers, and you want to practice, because there is nothing scarier than coming into an incident without being prepared and without having done it before, and this is the same for security. Thank you very much. My name is Max, and I'll be around all day, so happy to talk to you about security.